Hello. Today we're going to be talking about absolute value, and knowing the definition of absolute value is really the key to being able to do most of the stuff we're going to do in this section. Now, the definition for absolute value then is the distance a number is from zero on the number line. So in our first two examples, we're asked to evaluate. We have to find the absolute value of 7 in my first example. And the absolute value of 7 is, well, if I were to create a number line, I'll put 0 here, and I'll put the number 7 here. So the number 7 is sitting right there on the number line. So how far is it from 0? Well, its distance from 0 to 7 is 7 units. So the absolute value of 7 is 7. How about negative 3? If I put 0 here, negative 3 would be sitting over there. And so this is where I have the number negative 3. And what is its distance from 0 on the number line? Well, distances are always positive, so if you just counted over 1, 2, 3, you'd have 3 units. So the absolute value of negative 3 is positive 3. Okay, so that's the distance from 0 on the number line. So let's try these. Now we have some equations to solve involving absolute value. Notice we now have an equal sign, so our directions would change from evaluate to solve. So what we have first is the absolute value of x equals 6. So what I can do is read this as the distance from x to 0 is 6 units. So what does that tell me? If I draw my number line, I'll put 0 right here in the middle. I need numbers that are 6 units away from that. And I can walk over 1, 2, 3, 4, 5, 6. And there's a number that is 6 units away from 0. I can also walk over 1, 2, 3, 4, 5, 6 to the left. And there is a number 6 units away from 0. So x could possibly be two things. X could be either 6 or x could be negative 6. Let's consider the same thing about the absolute value of x equals 9 in the next equation. Well, if the distance from 0 to x is 9 units, well, our x could be either 9 or it could be sitting at negative 9 on the number line. Both of those numbers 9 units away. Good. So, how about the bottom one? The absolute value of x is negative 3. Well, this one's a little more tricky, so let me draw the number line again here, and I'll put 0. Whatever x is, it is negative 3 units from 0. So how do I walk from 0 negative 3 units? And the issue is, because distances are always positive, we can't. So this doesn't make sense because I can't walk negative 3 units. I can only walk in the positive direction. This one has no solution. Or we can say null set by putting a 0 with the slash through it. Either way, we want to write that. So we've sort of come up with a rule here that when an absolute value is alone in an equation and equal to a negative, there is, let me make that look nicer, there is no solution. Let's try some more harder ones. Okay, so let's solve these equations, and now we have some stuff in these equations besides just the x. But the principle is pretty much the same. So whatever number x is, we're subtracting 3 from it, and that number's distance from 0 is 6. So if I do the number line thing again, here's 0. I can go over to 6. I can go the other direction over to negative 6. Both of these are valid options. So whatever I do when I take whatever x is and subtract 3 for it, it lands at either negative 6 or 6. So I can say that x minus 3 equals 6, or that x minus 3 would equal negative 6, and that's a minus sign there. So basically, let's just solve these now, because I can certainly get x alone. So on the left side, I'll add 3 to both sides, and we get x is equal to 9. The other one, I have to do the exact same thing. I have to add 3, and I get x is equal to negative 3. So we have two solutions. X could be 9 or negative 3. And we can certainly check these solutions by plugging them in. If I take the absolute value of 9 minus 3, that should equal 6. 9 minus 3 is 6. So does the absolute value of 6 equal 6? Yes, it checks out. Let's try the other one, and I'll use orange for that. So if I do the absolute value of negative 3 minus 3, we want to see if that equals 6. And I get the absolute value of negative 6 equals 6. And sure enough, negative 6 is 6 units from 0. So that checks out. Let's try the next one. I'm going to have some sort of x. I'm doubling it. I'm adding 7, and it lands 15 units from 0. So what numbers are 15 units from 0? Well, 2x plus 7 could be at 15, or it could have gone the other way, and 2x plus 7 could have landed at negative 15. So notice that when we rewrite these, we no longer have the absolute value in our equation. We don't need it anymore because we know what the definition for absolute value is. We're able to go ahead and just write these equations out and solve them. So I'll subtract 7, so 2x is equal to 8. Then I'll divide by 2, so x is equal to 4. Or, same process, minus 7, so 2x is equal to, that's negative 22. Divide by 2, so x is equal to negative 11. And those are our two answers. And again, we could check them. So let's go ahead and do that. So the absolute value of 2 times 4 plus 7, and hopefully that's 15. 2 times 4 is 8 plus 7. I get the absolute value of 15, which equals 15. Check. And we'll try orange again. So I'll put in the other answer. The absolute value of 2 times negative 11 plus 7 hopefully equals 15. 2 times negative 11, that's negative 22 that we have to add to 7. Negative 22 plus 7, that gets me negative 15. So the absolute value of negative 15 equals 15. Indeed it does, and we are done.